Well, hi, good morning. Thanks so much for joining me in my shop here. It's September 25th, and what I'm going to focus on today is the hum that's apparent in this radio. Now, for reasons, honestly, I cannot remember. It was so long ago. I replaced one capacitor already. I cannot remember what prompted it. So the replacement capacitor is sitting here, and the capacitor I replaced, or that replaces, is this one. Now there's his brother right there. But these two guys are doing the same thing, and I'm just a little surprised that I've replaced one of them. Here we're going to start by looking at the schematic and just get familiar with where hums could come from in a radio like this. We're looking at the power supply and the amplifier here. Power supply is here, and of course this is the amplifier. The amplifier signal is coming in at this end and coming out at this end. This is an interesting amplifier. It has a feature, or you could even say lacking a feature, which is really a problem in a lot of amplifiers. It has no output transformers to drive the speakers. Instead, the speakers are being driven directly out of these transistors here. And they're driven through a capacitor. So no DC goes off to the speakers. And the speakers, if we follow, these are the two here, left and the right. These two wires, if we follow them up, they go into the speaker switch, and then no doubt they end up at the speaker terminals here. So this is called an OTL amplifier, output transformerless. It's kind of a weird way of putting it, but that's the term that's used, OTL. So OTL transformers, or amplifiers rather, are considered some of the best amplifiers around because they do not have this output transformer. The audio output transformer is a problem. It's got obviously it's a coil, it's got impedances. It can manipulate the sound in undesirable ways. And that's eliminated. Plus, this is, if you consider this capacitor here to be kind of the replacement for the output transformer. It's not quite true, but you could think of it that way. This is a lot cheaper than having a transformer here, which takes up space, consumes energy, weighs a lot, costs money. These are still fairly large. They're thousands. And their job is just to let the audio through with enough strength to drive the speaker. That's why they're so large. Now the one I replaced is one of these two. I think it's this one, number 8. And for the life of me, this morning as I put this schematic up and just glanced at it before starting the video, and I just wanted to know which capacitor it was. In my head anyway, I've been thinking it's one of these all this time. So the thing about this is these are big, expensive capacitors, and yeah, just change them all, yeah, the hum will probably go, but so will the money go out the door too. So we don't want to be radical about doing this, and unless you've got the money and this is your machine and you're willing to, and you want to bring it right back so it's going to run for another 40 years, then just change them all. Buy some new ones, change them all. Let's just look and see what that would really amount to. So here's a 100. Oh, let me back up. You notice there's a couple sets of diodes here. Excuse me. So if we look at this set and this capacitor, we see that it's feeding the output transistors and the driver transistors. And that's about it. Maybe down here a little bit too. If we follow the other diodes and filters, there's two capacitors, there's a bit of a pi filter network here. It doesn't exist up here. This is 1,000, the same as this one. And then there's an additional that looks like 500 here, 500 microfarads. So you have a better, more filtered power line here. 20 volts. Did it give the voltage on this? I didn't notice it. I don't see it. Could it be much different? I don't think it can be too much different. So we have a separate DC filtered, better filtered power supply going back further in the amplifier. So you can see it's feeding these earlier amplifier transistors, and back here and back here. So the idea here is you need better filtered DC earlier in your amplifier, because a little hum back here is going to get amplified here and it's going to show up in the speaker. But you don't need quite so well filtered DC in the amplifier, because a little bit of like the same amount of hum existing here, let's say as a percentage, and I'm just going to make this up, say a 1% hum in this part of the power supply, you will not hear. It's there electronically, but you can't hear it, so who cares about it? So why over filter the output area when the real problem in the output area is to supply pretty good current? You notice through here the diodes feed through transistors. This one tain't no resistors feed through resistors, but here there aren't any. Why is that? There's more current flowing here, and resistors, well, look at, even these are 2-watt resistors here. So even the amount of current, less current flowing in here, still demands big resistors here. These are low value, they're only 82 ohms, but they didn't even do it here. You know, they could have done the same thing. They could have stuck 2 capacitors here, stick a little resistor in between. But the designers felt not needed. One big capacitor should do the trick. Now there is another capacitor back here, 25. Find the same thing down here, 25s. Same thing here. The same thing here. Now, are some of these related to the hum? Or if they were defective, would a hum show up? Not sure the answer to that offhand, but I think the general expectation is the hum is minimized here, and these capacitors are busy doing something else, not so much hum suppression. I'm not sure of that though. I'd have to look at this for a while to kind of sort that out. They're using a diode here to set the bias. That's what I understand this would be doing. Oh, maybe not. It's going down here. This looks like, I think, what's called a Darlington arrangement. Here. Yeah, this could be biasing this in here. My familiarity with transistor circuits in detail is low. Studied this stuff in college. That was a while ago. And never really studied this kind of thing. We didn't really focus on transistors. We were already into CMOS and other stuff, or specialized transistors. Your ordinary one was just up to us to learn that stuff kind of on our own. There's the balance control here. So how do we know where the hum is coming from? It could be down here, because maybe this capacitor's gone weak, or it could be right in the output. I guess one way would be to listen to the signal back here in the earlier stages. There's an easy way to do that. Just once in a while, things like the headphones are fed differently from speakers. Probably not the case here. Well, so what's going on is the headphones have a limiting resistor in them. So they're probably fed with exactly the same signal as the speakers, just limited with a resistor. And plugging them in does not look like it cuts the speakers off. Looks like you could plug headphones in. Well, that's interesting, because I have little speakers in my shop, and if I plug headphones in, I can probably hear the hum better. Just kind of counter to what I'm trying to do, but just for interest's sake, these remote speakers have resistors. Well, I don't quite understand that, but I won't study that. I don't really care too much about it. Let's go back a little further and see if there isn't some more fairly large capacitors. So here's another pair of capacitors doing the same thing that this is doing, just doing it much earlier in the amplifier. So the audio signal will be passing right through these. Now if these were weak, the output would be weak. And I did notice an imbalance in the sound earlier on, but I think it was a phantom. I haven't noticed it since, but we can take a look at that too. Well, interestingly enough, right in the middle of the schematic, somebody has handwritten the number 68 there. Back further, there's nothing here but small signal type capacitors. There's one here, that's a fair size too. Now in the receiver there were a lot of electrolytic capacitors, 6, 7, 8 of them, and I replaced them all, kind of shotgunned them. Paid a price for that, paid a big price for doing that, by getting one of them in backwards. I have quite a history of doing that kind of thing. But so what should we do here? Find out if the hum is present here. Maybe a little easier said than done. Look, the signal coming out of here is on either side of the balance control. If I can listen to either side of the balance control, I think I would be able to detect the hum if it were there. Balance control being an easy place to go and get the signal. Anywhere else, you're kind of fiddling right with the circuit a little bit. Like if I hook wires up here, I'm right on the base. You know, another way, of course, just put put these two output voltages, the power supply voltages, on my scope and look at the hum. The difficulty with that is we don't really know what hum level is a problem offhand. I mean, sometimes it's obvious when you do that. Sometimes not. Another thing I can do is I can do temporary paralleling. So I can grab 1,000 microfarad, temporarily parallel this guy, and see if the hum goes away. That's a very good way of doing it. That's the low commitment and high results, so to speak. And you really know the story if you do that. I'm attracted to doing that right off the bat, because that could just end. There would be no need to go through and start poking around in here if I can get the hum out just by doing that. My guess is it's this capacitor. Scratching my head about why I changed this one, not this one, and I just don't remember why. Maybe you may. You may remember why. I don't. It's kind of a moot point anyway. Although I did say there was an imbalance in the output, or so I thought. It could be because I changed this and did not change that. We have two different values of capacitor here now. So it's something we could look into if the balance seems to be way off. Well, I think the name of the game is just to get out a big fat capacitor and parallel this guy and see what happens right off the bat. Great. Wow, I just closed a deal on a 1940 something beautiful floor standing shortwave, multiband shortwave radio, the kind of thing I love working on. Fantastic. Gonna pick it up later today. Great. Just have to tell my wife about it. Now. Uh-oh. Okay. So here I have a few capacitors here. I have quite a number of these. This one won't work for it. This is a 10,000. Whoops. 10,000's a little too much. So 4,000, 25 volt, not enough voltage. This guy, 20 volts, 2,000. How about that? 1,000 microfarads, just what I'm looking for. 180 volts. No chance of this one being injured by pretty much anything I do. So this isn't the best thing to install, but this is a great one for doing some testing. We're going to hunt around and find out who's causing the hum. Okay, how about that hum? Let me make this thing hum. Okay, let me turn down the volume. Now I don't know if this hum comes across on the stereo, on your sound system, or through the video, but there's a nice warm hum here. It's not even all that significant, frankly. If you just turn the volume up a little bit, you never hear this hum. But let's just see what we can do about it. So what I want to do, I'm just going to clip this. Make sure I clip it right. So one of the two terminals has a black dot painted on it there. That'll be the negative. Now, is there another way they're saying it? Negative black. That's fairly clear. Okay, so negative is white wire. And we better just take another look. I'm sure of what I saw, but I'm going to stop and just look at that schematic and be sure of what I'm doing here. I'm going to locate the terminal I want to touch this against before my phone dings again. Okay, I'm going to switch the clip leader to a black clip lead, so black clip lead on the black terminal. Seems to make sense to me. Definitely the capacitor goes to the ground. You can see it quite clearly up here actually. Now this set is on. I'm not too worried about doing this. Just grounding it. Now let's just put this on the oscilloscope here and take a peek at what this looks like before and after. Ground. DC. So there's going to be a 20 volt signal here. 20 volts, this is 5 volts per division. Let's get it. I get a sweep going. And this be the capacitor right here. Awkward sticking my finger there. Let me just turn this off briefly. You don't want to short, you know, like shorting a capacitor is pretty exciting stuff. I don't need the excitement right now. Okay, I want that to come off. Okay. Power on. Ooh, this just went right off screen here. Let's see if we can bring it down. There we are. Okay, put another camera on it so you can see it better. Something going by here. Now let's see where the zero line is. It's way down below. Put this back on right off the screen. So how does that work? 5 volts, 5 volts, 5, 10, 15, 20, 25, 30, 35, 40 volts on there. Okay, hold the horses. We need to check something else out here. I thought it was going to be 20 volts, but maybe I missed something. And let's check it with this. Great thing about having a 180 volt capacitor here, I really can't damage that. Okay. DC 200. How do you like that? 40. Now how do they get 40 out of that? Well, they do, and that's not surprising, because this is where the power is needed in the radio. The power is needed to drive the speaker. The speaker requires power. Not much else requires power in here. So they've set up the power supply to deliver a higher voltage, 40 volts, and that's okay. I was just wrong. It wasn't written on this schematic. They're trying to trick me. So now we want to make and break this connection, but this, fair size capacitor is going to be sparky. So I don't want to do that. Instead, what we're going to do is first we're going to flip this to AC here. Put it up on the screen. And then we're going to magnify it until we can see what's there. And then I'm going to flip cameras so you can see too. Now I'm going to cause my machine here to trigger on the line. Trigger on the line. Trigger, come on, you're supposed to trigger on the line. What am I doing? I'm doing something wrong. Normal. Maybe normal. Well, as usual, I'm having trouble making my scope trigger. So it's either me doing something stupid here. 2, 1, norm. Can't get it to trigger. Okay, we'll just let it roll. You know, I can fiddle with it here if I want to. Kind of stop it. That's good enough. That's good enough. That's kind of weird. That's a weird looking hum. Huh. Okay, let's carry on. I'm going to shut the unit off. And I'm going to stick in the other capacitor and then turn it back on. So here we go, off. And we're going to go on here. It'll be a bang. Small little pop. That came out of the speaker. Okay, I don't want to. A little busy putting 2 clip leads on. Okay, that's one. That's the capacitor. And this is the scope. Good? Okay. Safety check. Did I put this capacitor backwards? You know, how stupid can you be? Well, I can demonstrate how stupid you can be. But I'm not going to. I'm going to actually look for the black dot. Yes, black lead. Yes, to the grounded terminal. No chance of it being backwards. Okay, hit the switch. What happens? Okay, we'll take a look at the scope now. It's smaller. It's a little bit smaller. I still hear it. This just doesn't look the way I'm used to seeing hums. I am more used to it, like a bit of a ramping thing. Not these little pippy things here. But that's what I'm used to. It doesn't really mean there's anything particularly wrong. So now this guy's got way more capacitance at this point than it calls for on the schematic, because I've added this one in. So the other one conceivably is still 1,000 microfarads. I don't know for sure that this is the problem and it's weak. Doubling it has done next to nothing. I don't think this is where the hum is coming from. Although there is that little hum signal there, that may not be what we're hearing. That may be inaudible. So we got to find another capacitor to try before settling in on things here. Okay, let's take a look at the schematic. So this is the guy just doubled up, and the hum carried on. So, well, maybe down here. So why don't I find this one? C5. It's a 500. If I add 1,000 here, for sure that's going to knock out any hum due to this capacitor. And I'll move the scope down here, and we'll see if that that bump isn't doesn't quite make sense, does it? Oh yeah. So the bump could be normal, and we're hearing something else down here. That's what I should be thinking. Okay, gonna do that. Power off. It's a great thing about transistor stuff is turn power on and off all you like. It's not a really big concern. Okay, we're going to take off the scope and then take off the big capacitor, which is going to be holding a charge. So we'd like to discharge it. The bang thing is fun, but it can damage your stuff here. I've got a what that is. That's a something with a brown third band. I'm not particularly particularly exciting, was it? When my children were young, I didn't know this, but they would come into my shop in another house where I live in another house. It's a long time ago now. They would fish out capacitors because I showed one of them how to charge a capacitor and discharge it. And they'd go down there and they'd charge capacitors and bang, bang. I didn't even know they were doing that. Okay. Now, we got to figure out which capacitor it is that I want to do. And I neglected to spot the number, so I'm just going to peek at the schematic myself. Yes, I did notice the number. The number is 5. C4 and C5 are in the same can here. What is C4? C4 is the other side. So this one capacitor is doing is a two-part capacitor doing both sides of the highly filtered 20 volt DC. So I've got to pick off the 500 side of it. Now that would be written on the can. Son of a gun. Let's see if we can see it on the can. I'm going to grab my scope camera here. Let's see if we can't see it with this. This might be upside down. I gotta fish the camera in the right way. And here we go. The set is off. I'm aiming right up at the ceiling light here. Let me just switch that off. My ceiling light has its own hum. That's so disappointing. A lot of my LED lights have hums and buzzes in them. It's very disappointing. Well, I can't read it. A little more light. So my light is actually, of course, my lights are all aimed downwards. I gotta aim one upwards here. So I'm looking for, it would be a symbol. They'll use symbols to indicate which terminal is which. I can't read any of that. This didn't work very well. I'm going to use a mirror. Let's look at the back side of it. I will use this camera though. Oh, that was the light getting readjusted. So I see a triangle, I see a half moon, I see a square with a blank. Nothing there. So this must be can grounded. So the can, you can see some solder like up at the top there. So they've soldered the can. The can's the negative. And two terminals there. So half moon or triangle. Which one is it? Okay. Put this back here. So I'm going to grab my mirror in the dark shop now. There. Take a look underneath there. Let me get this light back where it should be before it causes a disaster. Ooh. Okay, triangle negative. 1035 volts, 35, so it says 1035, 40, and that's the half moon. And then the last one, it's very hard to see. The other one's 500, wasn't it? Why does it not say 500? Does it say it and I just can't read it here? Looking at the right capacitor? Yeah. $1,000. Was there another capacitor? This was numbered. I don't get that. Well, this doesn't appear to be a two-size capacitor. Doesn't make sense. This doesn't make sense. This doesn't make sense. The two terminals, I don't need that. There's two terminals on this guy. On the radio. One's a half moon, the other one's a triangle. Didn't I say triangle was ground? It's supposed to be a two-part capacitor. I'm talking about the one right below here. Something going wrong with how I've done this? How can that be? It looks pretty much like this one. I mean, these two look identical, but you can see up here. Try and see it directly. Okay, I have to get to the bottom of this before I go any further. I'll spend a little bit of time studying it here. Okay, that didn't take too long. I'm looking at the wrong capacitor completely. Of course, it's over here. Now, these are the output capacitors. They look identical. They are identical. One of them I've replaced with this, but I didn't do the other one, which, you know, what was I doing? I guess I was confused, similar to how I am now. Okay, we'll go back over here. I don't know. I just don't remember. This one up here is the one that I should be investigating, and it says on it, oh, it's got three sizes. 500, 500, and 500. Okay, so that's how you get a 500 and 1,000. You add two 500s, you get 1,000. It's pretty good, eh? I can handle the big numbers really well. So, okay, so now something's grounded up here. So there's two terminals tied together there. So that's the 1,000. And the other one is going somewhere else. And again, it looks like the can is soldered. All these are soldered to the chassis. Sometimes these power supply capacitors are insulated away, like this one, for instance. This one, even though it's got this nice metal bracket, there's no contact between the bracket and the inside of the capacitor. You need to spot those things. That's a big hint about how things are wired in the radio. So in this case, we just want to go first our hum check, and we want to do the 500 side. What we're going to do, why the 500? It's the second side, and my God, I'm going to add 1,000 to the 500. Boy, that'll make a difference. If the hum is there, that should kill it. So first, we're just going to look on the scope. And have I done the right thing? Because we're fooling around in the power supply. The wrong thing can be a little more painful. It's fine. Okay, power on. Now, let's take a closer look at the oscilloscope. Okay, now I'm going to go to DC, and we're going to try to find it. And it's not on the screen. There it is. Okay, where's the 0? There's the 0. I'll set the 0 right on one of the lines right there. That's now the 0 line. I'll go up like this. It's gone. 1, 2, 3, 4.5. 4.5. And can you see the hum? I can't see it. I can't see it at all. Now we can zoom in. If I flip this to AC here, raise it up a little bit, and I will zoom in on it. So of course there is a hum. There's always a bit of a hum there. The question is it so low you can't hear it? Now as a percentage of the power, it's tiny. But, you know, this is going into very sensitive circuits. So, I am going to hook up that capacitor, but I'm going to do it first by turning off the power. And now we're going to hook up a 1,000. What are the risks of hooking up where you want 500? Now there's going to be 1,500. The risk is during the charge up, of the 1000 and the 500 together, it will burn out a resistor. What is the degree of risk there? These are high wattage resistors. I'm looking right at them here. Here, you can look at them too. These are high wattage resistors. And here, they take time to heat up. Lots of time. And these can go really hot. These guys can go really hot. You don't want them really hot, but they can go there. So risk is really quite minimal. Smaller resistors, not right, in my own opinion, not likely to suffer damage. Okay, so we're hooked up properly and we're ready to go. Okay, let's watch the scope for the tremendous excitement and listen. Here we go. Well, I don't hear a hum anymore. No hum. I'm now going to disconnect the auxiliary capacitor. Voila, la hum. Okay, so we've identified a place we can add capacitance to knock out the hum, but I've used a stupidly large capacitor. We could use that. Put it in there. I think the set would be just fine. The only reason they don't have 1000 in there now is because it was cheaper to do 500. They can get away with it. So economics are always pressing down on everything that's being done in these sets. So smallest capacitor possible, especially an expensive part like these capacitors. They're quite interested in trying to reduce them, and physical size and weight and everything. So I need to augment that. Do I need to replace it? I don't think so. There could be a little bit of a leak through it. There's these big capacitors do tend to leak a little bit, but a little bit is a little tiny bit. So I don't think I'd worry about that. I think I'd just add in. Well, what if we add in 500? And did I measure the voltage there? Now there's another whole way of doing this. Let's try another way. With the hum there, we know the hum is there. We take E-volt voltmeter. I have to measure the DC voltage here anyway. I think it should be 20, but I thought that earlier about another spot. So I'm watching the meter now. 21 volts. Okay, so it's a 20 volts as it says on the schematic. Now we flip this to AC. Now that my meter's only good, well, that's 2 volts, so it does go down a fair bit. What do we read? I'm trying to read the hum alone. Some meters, by the way, you really can't do this because the DC voltage will push current through. You'll get a reading on the AC meter with the DC voltage. So if we get something crazy here, like 20, we'll know this isn't working right. Okay, so we're not getting anything crazy. We're getting pretty much nothing. That's down to 0.003. 0.003. So what is this hum voltage here? So we're on 20 millivolts per division. We would have read the RMS value of this. The peak to peak is roughly 10 millivolts. We're right down in that range. Peak to peak is 10. Peak would be 5. Divide by multiply by 0.7. 5 is going to be 4.004, somewhere in that range. And this is just a false reading now. Similar. So I think that's adding up. I think everything is adding up nicely. Okay, so I'm now going to find a permanent. Oh no, not a permanent. I need to find a 500 I can test with. That's a 500. Okay, I don't think I have one out here. I'm going to dig out a 500 and we'll see what happens when we just add 500. I'm very fortunate to have these parts here. 500. 560 at 200 volts. Oop, too many leads. Too many leads there. Why so many leads? 2 and 4 not connected. So those must be just terminals for making connections. 2 and 4. So it's just these two. So that would do it. I certainly do it for a test. What else do I have here? That might be around 500. 300, 300. 2000. 300. Ooh, look at this guy. Now that's more for a tube radio. So I think I've got what I need already, certainly to do the test. What was this guy? 10,000 at 71 volts. Gold colored. Put that in your expensive stereo. Hum away with it. Okay, so that in fact could become the permanent replacement too. 560 negative is the negative. So they've stamped right on here. Negative. And they've stamped this as number 3, double checking. 3 is 200 volts. Okay, that's good. Okay, power off. Now we want to clip lead this temporarily again. So we're going to take this off the negative and put it on the negative. And these clip leads aren't necessarily the best way to do this either. I tried to pick my very best clip leads. There is no such thing. And we're going to put this on here. Excuse me for showing you my big heavy sweater. A little cold in the house these days because we don't have our heat on yet. And it's getting cold out at night. Okay, I'm going to move this out of here. Because it's just too much stuff around. Guys out of here. There we go. Okay. Now, is that going to do the hum trick? Everything's good. We're good. All is good. Let's watch the result. 3, 2, 1. So I do not hear a hum. I do not hear a hum. See, there's still a little bit of hum there, but look, this hum is in the range of the RF noise in the circuit. That's tiny, tiny, tiny. So we are down to some tiny amount. Now the trick here is I'm using relatively small speakers, and because I could hear the hum with these little speakers, I mean these little guys, that little guy up there, and his brothers over on the other side here. If I can hear the hum with those, then I can't be sure that, because I can't hear it now, the reason I can't hear it is because of those speakers. So I need to get some headphones in here, get some good headphones in here. Okay, I've got my fairly decent AKG headphones. These are well-known headphones. These are K240s. Made in Austria. I didn't know that. If you ever see something like this at a yard sale, buy them right away. That's what I say. Okay, I get to hear it. You don't. Oh, the set is on. So there is a very faint hum. Very faint hum. Turning up the stereo here. Hang on. Yeah, Now, you know what? Maybe this hum is not even to do with this. There's hums in my shop. I gotta turn this off, see if, and the hum goes away. Okay, so I can hear the hum. Question now is it so low that who should care about it? Just like on a record, when you play a record and the needle is going between songs, so it goes into the quiet spot. You hear all the clicks and pops and clicks and pops. Go, it's a terrible record, it's a horrible shape. But as soon as the music starts, you can't hear any of that anymore. Hiss, hums, they're all even a high level of noise can be just covered over by the music, by the program material. And that's what you listen to, right? You listen to the program material. Don't get too preoccupied with listening to silence and a little hum and a little hiss. I think it's a suitable fix myself, but if I really want to be sure, I've got to bring a big honkin' speaker in here. You know what? I think I'm going to bring big honkin' speakers in here. I think I bring at least one. Okay, I brought in a big Thunder Dunder speaker here. This is the speaker I listen to all day long on my TV. This is a Technics speaker. These are not well regarded by audiophiles. I don't know why. I don't understand audiophiles at all. Look at that thing! Holy smokes! Look at that! So if there's a hum, we're going to hear it. This is a Technics super bass loading. What they're talking about is this port down here. SBA 50s. I saw these at a yard sale. Pair of them. In good shape. It's kind of a cheap cabinet here and that. But I like the size, of course. Techniques, how wrong can you go? Got a whole chart here. Come on, they gotta be good speakers. What do you want for those? $10. $10 each? No, $10 for the pair. Sold. Yes, that's what I paid. $5 for this speaker. Now, I still have the other little one hooked up on the other channel. That's not going to matter. And I've also disconnected the augmented capacitor, the augmentation capacitor here. It's not connected. So we're going to hear the hum through here. I'll find out for the first time what the hum really sounds like in this radio when hooked up to a big speaker. The great thing about this guy is this is bigger and better than anything that's in the cabinet for this stereo. And I have to show you a picture. I'm going to do it right now. I'm going to show you a picture of what this stereo really looks like. I don't think I've done it on any other video. So I'm going to do that now. Just bear with me a moment here. Now this is not the actual one. This is a example of one, but this is what this is what I'm working on. So I have the record player and the receivers on my bench here. And do you see the speakers on the end of this thing? This is a crazy looking thing, isn't it? Look at the speakers. No. Okay, Art Deco, I guess, or Super Mod, I'm not sure what to call it. I'm sure speaker designers are horrified by looking at those, but there's no guarantee that there's anything wrong with them. But they aren't going to produce the bass, I would imagine. They won't produce the kind of bass that this big honker is going to produce. Isn't that fantastic thing? And I'm pretty sure the owner has the plastic covered there. I think he does. Might be something that would disappear on a lot of these. So that's wonderful. I wonder how many of these are floating around still in the world, because look, it's a little ungainly to have that in your house. Wow. Okay, back to what we were doing. So we're going to hear it right out of the speaker as soon as I hit the switch. Here we go. Okay, so what I'm doing here is I hear a hum. It doesn't sound much different than it did. Frankly, this not terribly disturbing, even like this. Okay, I'm going to hook up the augmentation capacitor. Let the proof be known. Hit the switch. Zero hum in my opinion. I don't hear a thing. Fantastic. Okay, it's passed the test. So that's the capacitor that's going to go in. And going to permanently eliminate the hum out of the receiver. Excellent. Excellent. Happy day. Oh, wait a minute. There's one thing I didn't do. I didn't actually make this play. Make this play. Oh yeah. Okay. Just making sure. Now there's quite an imbalance there I could hear, but then this speaker probably doesn't produce the volume that my little speaker produces. This one takes a little more power to get the volume up probably on it, but it's definitely working. Good. Well, that's just great. I got that speaker back into my rec room there, hooked up before my wife never knew I took it out and brought it here, because if she ever saw me do that, she'd say, don't bring that big ugly thing back in here. Get that other one out of here too. Get a power bar, get like a sound bar and 2 little speakers. Oh, okay, good, got away with it. So I'm not going to install this today. I'll do it on my own time. I'm not going to do it on the video. I'll find a place just like this one. I'll strap it in somewhere and wire it up. No big deal. Tomorrow we're going to get back to the, oh, I hate to say it, alignment issues with this radio and the lack of stereo, and see if we can't sort that out one last time. So thanks a lot for watching, and hope you enjoyed that. I did. And now I'm on my way to the Toronto International Airport to drop somebody off, and on the way back I'm going to stop at someone's house and pick up a 1940s great big floor model radio that I succeeded in buying. And then somewhere down the road, I'll be working on that radio in here. Fantastic. Great day. And the sun is shining today. Man alive. The list of good things is long today. So, see you tomorrow.